One of the most important applications of integrals is finding the average value of a function. It's one of those things that comes up quite a bit. So I'll give you a picture first and I'll show you what it actually is, and then I'll give you the formula for it. So let's say that we have a function. I'm just going to make it look like this. The average value of this function would be what you were to get if you took all of the y values, added them up, and divided by the number of y values. It's the basic idea. Now, because there's an infinite number of y values, we can't do that. But what we can do is use integrals. So like if we had a function like this, the average value would end up being like somewhere around here. And make sure that you keep in mind it is a y value also. So that's our average value. So I'm going to go ahead and give you the formula for this. So here's our formula for the average value. Now you need to have a starting x value and an ending x value. I didn't actually put that on my graph, but just assume that we included that. So you need a starting and ending value. Your average value is going to be 1 over the higher value minus the lower value times the integral from a to b of whatever your function is. So I just want to make sure that you are aware of the difference between the average value and the average rate of change. Those are different things. But I do want you to recall that we did the average rate of change at one point, which was this, f of b minus f of a over b minus a. It almost looks similar to this, but it is actually, it's a different thing. So please be careful. Make sure you know if they're asking you for the average value or the average rate of change. It's just a few words changed, but it's a different meaning. And I'll actually give you an example of that in just a minute. So here we're going to find the average value of the function f of x equals 1 plus x squared on the interval from -1 to 2. And I always like having pictures. I think it's really, really useful and helpful. So I am going to draw a picture of this just so we kind of have an idea of what we're actually looking at. This is a parabola. It has a y-intercept at 0, 1, and it's going to have points here and there. So it's going to look kind of like that. So that's my graph. So now the average value of this, and you're welcome to pause and do it on your own, but the average value using that function, I'm going to write it like this, f average. I tend to often write it with a G, by the way. Your book writes it with an E. Doesn't really matter as long as you write it in a way that makes sense to whoever's grading it. So using the formula that we had, we're going to do 1 over the highest x value minus the lowest x value times the integral from, in this case it's -1 to 2, of that function. So we end up getting 1/3, and I'm going to go ahead and find this integral. It's going to end up being x plus x cubed over 3. Keep that 1/3 out front until the very end. It makes it easier for me personally. So I end up getting 2 plus 2 cubed over 3, which is 8 over 3. That's the first part of my integral. Minus the second part of my integral is -1 plus -1 over 3. So I end up getting 1/3 and times all of this stuff. I'm going to show you my little trick for these. If I distribute that. You might notice that I did not get a common denominator for everything. Actually, what I'm going to do, I'm going to put together the 8 over 3 and the 1 over 3, and I'm going to put together the 2 and the 1 separately. That makes things go a little bit faster because that's going to be 9 over 3, which is 3. So I get 1/3 times 6, which gives me an average value of 2. So if we were to look at this graph, we started at -1, we ended at 2. So what that value 2 says is that over that interval, there is the same amount of graph below that line as there is above that line. So that's what that average value is actually saying. So I did mention earlier the average rate of change, and I do want to talk about the two different averages that we have by using the example of average velocity. So right now, we have two ways to find the average velocity. We only had one before. The first way of finding the average velocity is by using the equation we just got and taking the integral, finding the average value. That would be the first way of doing it. You also have an option of doing that using your average rate of change formula. However, velocity is the average rate of change of the displacement. So you would actually take your displacement and then you would use the average rate of change. So I just kind of wanted to give you like the difference between the two and give an example of it. We will do like a more specific example of this type of thing with numbers in class, but I just wanted you to see that we do have several ways of finding this. So we're going to be using the average rate of change formula, but you need to use that with displacement. That's what that S is, by the way.